It's Metal Clock with Mr. Hlajwayo. Welcome to another video.
So we are going to be examining Theorem 9. So according to Theorem 9, we are going to be proving that the angle that is subtended by the arc in your tangent is equal to the angle that is subtended by your circumference at your cycle, right? So basically now, the first thing that you are going to do here is, you are going to provide construction. So you're going to start by firstly constructing your diameter. You're going to start by constructing your diameter. So you're going to construct, you're going to let this be your D. So you're going to construct line AOD. You're going to construct line AOD, or rather diameter AOD. You are also going to then construct the chord. Your chord, which is your chord DC. These are the two things that you are going to firstly provide constructions of. Then after that, you are going to let this be your A1. Say this becomes your A2. Similarly, what you're also going to do here is you're going to let this be your C1 and also your C2 here. Now, what is the first thing that you're going to do? Let's start here. Now, if you can start by firstly angle A1 plus 2. Can you see that you are having your diameter which is perpendicular to your radius, right? So you are going to say now, if you add your angle A1 plus your angle A2, this is going to equal to 90 degrees. What is going to be your reason? This is because your tangent is perpendicular to your radius or your diameter, right? Your tangent perpendicular to your radius. Okay. Now, again, if you can look at this, if you can look at C1 plus C2, remember your AD is your diameter. And according to Theorem 3, an angle that is subtended by a diameter, it forms a 90 degree, right? So which means basically, now from here, this angle is also going to form a 90 degree. So you are going to say your angle C1 plus your angle C2 is therefore going to give you your 90 degrees. The reason behind that, this is going to be because an angle in a semicircle, right? This is an angle in a semicircle, right? This is your angle in your semicircle is equal to your 90 degrees. And now from there, what is it that you can do? Look, let's look at this one. If you can check, can you see that now? If you can look at your angle A2, your angle A2 is equal to your angle C2, because these angles are from the same arc, are subtended by the same arc, which is this arc, which is arc BAT. So you're going to say now your angle A2 is actually the same as angle C2. What is going to be your reason there? Your reason is going to be because these are angles on the same arc. Remember how to write your arc ARC, right? This is your arc. So now let's move from here. So you see that now your angle A2 is equal to your angle now C2. So therefore, what is it that you're going to do? Is you are going to now say, now what you are required to prove? You're going to say now from here, your angle A1, isn't it that your angle A1 is going to be equal to 90 degrees. Subtract what? Your A1 is equal to 90 degrees, subtract your A2 when you transpose your A2 to this other side. So it's going to be subtract your angle A2. Similarly, your angle C1. Your angle C1 is going to be equal to your 90 degrees. Subtract what? It's going to be 90 degrees. Subtract your angle C2. But can you see that your angle A1 is 90 degrees, subtract A2, angle C1 is 90 degrees, subtract C2. And you are subtracting the angles that are the same, right? So therefore, you can then conclude that actually your angle A1 is going to be equals to your angle C1. This is going to be because of your tan chord theorem. Remember, this is your tan chord theorem. This is your tan chord theorem. So this is because you are required to prove that actually your angle A1 is equals to your angle C1. Therefore, this is how you go about when proving this. Remember, just a recap, you are required to prove that A1 is equals to C1. The first thing that you do, you provide a construction of your diameter, and also you provide a construction of your chord. Then A1 plus A2 is going to be 90 degrees because this is your radius, which is perpendicular to your tangent. Therefore, this is going to be equal to 90 degrees. This is going to be equal to your 90 degrees. Similarly, now your angle C1 plus C2, because this is your diameter, and an angle that is subtended by a diameter is equal to what? 90 degrees. So this is therefore going to be equal to 90 degrees. Then after that, what is it that you are going to do? Now A2 and angle C2 are going to be equal to, they are going to be the same, because these angles are drawn from the same arc. Then therefore your A1 is going to be 90 degrees, subtract your A2, C1 is going to be 90 degrees, subtract your C2. Now that you are separating 90 degrees with angles that are the same, then you can conclude that your angle A1 is equal to angle C, because all of them are equal to the same thing. Then that's your theorem 9, which proves your tan chord theorem.